Hello there. In this video, I'm going to talk about greatest common divisor and least common multiple of numbers. And I've got two examples set up for each. And I'm going to go through the process of how we can computationally prove what a greatest common divisor is, and then give you a tip on how to do least common multiples. Now, greatest common divisor, what does that mean? The divisors are the numbers that can divide evenly into numbers without any remainder at the end. The greatest of these would be in a pair of numbers, or maybe you're comparing 3 or 4 numbers, that it's the absolute biggest that divides all of them evenly. Now, how can we show this from a mathematical perspective? I'm always a fan of factor trees, so what I'm going to do is I'm going to create a factor tree of 90 and 54, and I'm just going to go ahead and break down all the numbers into their prime factors. So I know that 90 is 9 and 10. Now again, these numbers are small. The number may jump out at you right away what the greatest common divisor of 90 and 54 is, but I'm just going through the process to know how we know this is the absolute greatest. And in breaking it down into its prime factors, I get 3 and 3, and 2 and 5, and then 54. I know that's 9 and 6, 3 and 3, and then 3 and 2. Okay. So now we've got one right here, and notice we got a 9. And it's tempting to want to say that's the greatest common factor. But notice in our prime factors, 90 has a 3, it has a 3. So does 54, it has 2 3s, which would lead us to think the greatest common divisor is 9. But notice they also have a 2. So they have common prime factors of 2 3s and a 2. These would be all common factors or divisors that they have, and how we can figure out our answer is just multiply them back together. 3 times 3 is 9, times 2 is 18. That means the greatest common divisor is 18. Let's try the greatest common divisor of 91. So we'll create a factor tree of 91. Now I happen to know that 91 is a factorization of 2 prime numbers, 7 and 13, and then 51, well, there's a 3 in there, and then I believe there's a 17 as well. So really quickly, if I'm doing my long division to check, 1 3 goes into 5, so that's minus 3, 2, 1, yep, 17 indeed. Just checking my work. Now, this does not have any common factors. And really, what I should say, it doesn't have any common factors other than 1. Remember from the divisibility video and rules that we just have 1 is a divisor of everything. So 2 numbers will always have a greatest common divisor. It's only interesting, though, when it's greater than 1. Okay. So that's how we work through the greatest common divisor. You may be able to do this in your head. That's perfectly acceptable. When you need something, you can always break it down into its factor trees and see what's in common. So let's go ahead and talk about least common multiple. Now, the least common multiple would be if I'm multiplying a number, or rather, what is multiplication? I'm adding it repeatedly. So I'm adding a number again and again. So let's start with 7, since it's the smaller of the 2 numbers. If I add another 7, I get 14, I get 21, I get 28, and so forth and so on. So let's go ahead and try that with 12. 12, 24, 36, and the common multiple appears when I get the first number that it's common. Now, they don't have to align perfectly in this row. In fact, they won't. So let's go ahead and do some more. So we got 42, 49. I'm going to run into the other problem, so I'll start a new line. 48, we get 60, 72, 84. I'll create a new row for 7. What about 56? No, 63, 70. But I notice if I go 2 more, 77 and 84, it looks like 84 is our answer. That's the first number that we got in both rows that is common. So our answer here is 84. Now, if we're talking about multiple, the word multiply comes to mind. Say, hey, can't we just take 12 times 7 and we get 84 as our least common multiple? And the answer is yes, but only in a very specific circumstance. So let's try 6 and 9 and see what we get. So 6, 12, 18. I'm going to stop there because I know that if I do 9 and then 18, I get 18 as an answer. But if I try that trick of 6 times 9, I get 54. So here's where we have to take a cautionary tale. If you're looking for the least common multiple and we try to multiply the two numbers together, you will get a common multiple, but you will not necessarily get the least common multiple. And that leads us to, when can we do this? Well, if we look at the GCD, the greatest common divisor of 12 and 7, again, small numbers, but let's create our factor trees anyway. We get 3 and 4 and 2 and 2 from 12. And then 7, well, that's a prime number. We don't have any greatest common divisor other than 1. So the greatest common divisor of 12 and 7 is 1. What about 6 and 9? The greatest common divisor of 6 and 9. I know that 6 breaks down into 2 and 3. And 9 breaks down into 3 and 3, and we've got a common factor of 3. So that means my greatest common divisor of 6 and 9 is 3. Notice this leads us to the rule that when we get a greatest common divisor of 1, by all means, just multiply the two numbers together, and you get your least common multiple. But what happens when the greatest common divisor is not equal to 1? Do we have to resort to this listing numbers out? What if I have numbers that are billions long? Well, the good news is we have a formula we can use. So the least common multiple of two numbers, A and B, I'm going to write that a little bit more on the level, A and B is equal to A times B divided by the greatest common divisor of A and B. So if we try this with 6 and 9, we know 6 times 9 is 54, but then if we take 54 and divide it by the greatest common divisor of 3, we get 18. Really quickly, if I want to do a mathematical proof for this, it's because if I break down the factors, so 6 times 9 would be the same thing as 2 times 3, 3 times 3. We have that greatest common divisor of 3 and 3 in each that we are double counting. So get rid of one of them, and we end up with 2 times 3 times 3 is 18. Please remember to like and subscribe. Here are more videos if you care to watch them. And leave a comment in the comment section, and I will see you next time. Thanks for watching.